They say which of the following statement now question 4, because I was explaining to you how you identify something functions not function. So now let's go to the question. Which of the following statements is or are true? The first one, the relation defined by y is not equal to x is the function. Alright, so let's go first. What do they mean? Excuse me. So what is y is not equal to x first? Thank you guys, so that you get to understand y is not equal to x. When you say y first, what is y equal to x? If I have a Cartesian plane, this is y, and this x Cartesian plane. Y equal to x, this is a line here. Y equal to x. This is y equal to x. So now when you say y is not equal to x, what does that mean? Means everywhere. We go to the question 4. So the question 4 say which of the following statements are true, or which of the following is or are true. So the first question, they say the relationship defined by y is not equal to x is the function. We're gonna have to check whether it's true or it's not true. The second one, B, say the set of we have a relation there, which is 1 and 2, 3 and 2, 4 and 2. So I'm gonna show you how whether this is true or it's not true. The C also say the set of x are element of real number. Y equal to square root of x is the function. Okay, now those are option, only A, only B, only C, etc., etc. So now let's go to the solution, right? Go straight to the solution. So in the solution, they say, okay, so the first question, they say, excuse me, the relation defined by y, the relationship defined by y is not equal to x. Alright, so first of all, guys, man, you know, I'd like to explain to you how do you know how to identify something's function, or instead of function, the function is not function. For example, how do you test a function? For example, if somebody give you, excuse me, this is quadratic. I hope everybody know quadratic. So this is a Cartesian plane, y and x, and then you have a straight line here. Is this a function? Yes, it is function. How do you test something? A certain function, a certain is a function. Why? Because you test a function, you draw vertical line. See. If you draw vertical line, and if you cut only once at every point, then there's a function. Okay. What about this one? Is this a function? Yes, it is. Why? Because if I draw my vertical line, see it cut once at the graph at every point. What about this one? Yes, it is. Because if I draw vertical line, it cut once. You see, at every point it cut once. Every point it cut once. So yes, it's a function. So all these are function. What about this one now? This is Cartesian plane, like I say. Okay, let's draw a vertical line. Test. Oh no, it's not function, because when I draw vertical line, it cut more than once. So if it cut more than once, then it's not function. You see what I'm saying? So this is not function. It's not function. It's not function. Not function. So how do you test a function? Draw vertical line. If it cut only once, then it's a function. If it cut more than once, then it's not function. Okay, what about this one? Is this a function? It's a Cartesian plane, and they have a cycle here. Is this a function? Okay, let's test now. So we're going to test by drawing what? Vertical line. No, it's not function, because when you draw vertical line, it cut more than once, so it's not function. So it's not function. Oh, so now we get it. Oh, so to test a function, meaning you have to draw a vertical line. If it cut only once at each point, at every point, then that's a function. If it cut more than once, that's not function. So these two are not function, because when you draw vertical line, cut more than once. They're not function. Okay, one-to-one function. Now we go for one-to-one function. One-to-one function. One-to-one function. Okay, so one-to-one function, now you test it by drawing the horizontal line. So to test function, you must draw what? The vertical line. For function, you must test using what? Vertical lines. And it must cut once. Cut once at every point. Each point at every point on the graph. Every point on the graph. Okay, so now we want to test one-to-one function. First of all, to test one-to-one functions, a certain graph or a function, it must be function first. You can't test one-to-one function if it's not function. For example, somebody give a graph like this. Is this one-to-one function? So how are we going to test? By drawing the horizontal line. So one-to-one function, you test by drawing what? Horizontal line. and it must cut once. Cut on once at each point. At every point. At each point. Every point. So now, before you test one-to-one function, you must test face if it's function. Because if it's not function, even if you're going to test horizontal line, and then it's accepted, but then it's not going to qualify. So now, before we test one-to-one function, you must test face if it's function. Is it function? Yes, it's a function. So when you identify its function, now we draw what horizontal line to see if it's one-to-one function. Oh, it cut once. Yes, so this is one-to-one function. One-to-one function. Okay, let's check some more. Okay, what about this one now? So you see this one. I want everybody to try this. Is it one-to-one function? So let's taste. Yes, is it one-to-one function? No, it's not one-to-one function. You know why it's not one-to-one function? Even though it cut once at every point, it's not one-to-one function because you should have tested face if it's function. And if you test the function, disagree, it's reject. You know why? Because it cut more than once with a vertical test. So face before you test one-to-one function, you must test if it's function. You see? I'll do it again. So face you have to test if it's function. How you test the function? Horizontal line. You see? Cut more than once. So since it cut more than once, is not function. With the vertical test, not function. So if it's not function, it can't even be one-to-one function. So even if I'm going to draw horizontal line and see it cut once, you see it cut once everyone. Cut once everywhere. Cut once. You see it cut once everywhere. But since it was not function, then it can't even be one-to-one function. Okay, thank you so much for that. Okay. So now, let's go to the question now. When you say y equal to x means this line is y equal to x. So according to the equation there, they say y is not equal to x. What does that mean? We know y equal to x is a function. How do you know y equal to x is a function? Because if you draw a vertical line, look, let's try to draw a vertical line here. Let's pretend like we draw a vertical line. Oh, it's the function cut once at every point. But for this case, they say y is not, look here, they say y is not equal to 1. Right here, y is not equal to 1. So what does that mean? So y is not equal to 1 means it can be anywhere except this line here. So y is not equal to 1 means other place except here. Means it can be anywhere but except this part here. Means it's not equal to that one. So it can be all other place but not that one. So I'm saying, so we know this function. So if it's not that place, mean the other one should not be function. Is not function because y equal to x is the function. But for this case, the relationship defined by y is not equal to x, meaning they say it's function. No, it's not function. Look, because you say y is not equal to x in other way means it can be other region. So I'm saying means, okay, I'll say it again. Y equal to x, no, we know it's function. We have tested now because how we test function, draw vertical line. We see, oh, it's function because when you draw a vertical line, it cuts everywhere once. So you say y is not equal to x, meaning all other region. But all other region, somebody could even draw something like this. Look. How if somebody draws something like this? This is another region also. It's not part of y equal to x. Can this be function? No, it can't be function. You know why? Because if I draw vertical line test, it cuts more than once. And this is the other region apart from y equal to x. So this part here can be part of y is not equal to x. Yes. Even part of this one means this is y is not equal to x. Because y equal to x is this region. So y is not equal to x means these other party. Anywhere apart from this part. And it's not true, it's not function because I can test it say it's not function. So if this is function, but they say it's not that one, what does that mean? Because this is y equal to x, but they say y is not equal to x. If it's because y equal to x is function. So if it's not equal to x means it's not function. So for that case, according to the option there, the relationship defined by y is not equal to x is a function. I say no, it's not true. So that's false. A is false. So I'll say A is false. Okay, so now we go for the option B. For option B, they say, they say option B, the relationship, I can draw a graph for that one, man. Let's draw a graph, man, like grade 1. Okay, so I'm going to draw a simple graph like grade 1 here, Cartesian plane. Let's draw a Cartesian plane. Okay, Cartesian plane. This is y, this is x, Cartesian plane. And how do they say? They say, let's represent this set. 1 and 2. So x equal to 1. What the value of y? Y equal to 2 means when x equal to 1, y give us 2. Look, y equal to 2. I mean, this is the coordinate here. 1 and 2. Okay, that's the first coordinate. The second one. Okay, the second one is say 3 and 2. So all of them, they have the same value of y. Look, all of them, they have the same value of y. 2, 2, 2, 2, 2. So it's like, okay, 2 and 2, it's going to be 2. No, the second 3 and 2 means this is 1. This is, let's say, 3, 2, and then 3 and 2. It's going to be 3 and 2. So you see, all of them, they have the same value of y. The third one, 4 and 2. Mean this is 4, and this is 2. Fourth one, 5 and 2. Excuse me, 5 and 2. The next one, 7 and 2. 7 and 2. So you see, all of them, they have the same value of y. So, okay, so this is going to be our line. If you have to represent those data, those sets of data on a number line, on the Cartesian plane. So what that means that, excuse me, this means, excuse me, sorry, just a second. So this meaning, right? So if you had to represent all this set of data in Cartesian plane, it's going to look like that. So let's test if it's a function. How are we going to test? We know how to test. Let's test. We're going to have to draw the vertical line. So let's draw a vertical line test. Oh, so vertical line test, it shows it cut once at every point. So if it cut once at every point, mean this is a function. Okay, so B is true. So option B is true. B is true. Okay, so now we go for C. Option C. So option C, excuse me. Option C, they say, for option C, let's take a question. They say option C, that's how you say, the set of element of X, we have a curly bracket, the set of element of X are a real number, whereby Y is square root of X is the function. Y equals square root of X is the function. Okay, let's go. So we can draw a simple graph here like grade 1. Let me do like grade 1, man. Okay, but it's not necessary, but I'll just show you quick how to do that, and you want to check is a function. So Y equal to square root of X. Let's put in the Cartesian plane. So this is X and this is Y. So now let's start with 0. Okay, when X equal to negative, no, it's not going to work because we cannot square root negative number. So there's none of the number on the negative side is going to work in here. No, they're not going to work. For example, when X put negative 1, if you draw table value like grade, oh, let's do like grade 2, man. Grade 4, grade 5, oh, grade metric or grade 11. 11, grade 12, grade 10, okay. X, and there you go, Y. What is a Y? Square root of X. We want to represent, we want to put this value in the graph and see if it's going to cut with a vertical test, okay. So we can plug the value of X, which is negative, because if you put negative here, it's not going to work. Square root of negative is not going to work. So we're going to start from 0 because you can square root 0. If you plug in here 0, it's going to be square root of 0, and square root of 0 equals to 0. So you're going to start with 0, 1, 2, 3, 4, 5, 6, etc., etc., etc. Let's test now. When X equal to 0, is going to be square root of 0, square root of 0 equal to 0, means square root of X equals 0, 0. If you put 1 here, but we're not supposed to use the calculator, so if you put 1, you're going to get to 1 also. Square root of 1 equal to 1. And then if you put 2 here, it's going to give square root of 2, but we don't need calculator. 3 also is going to get square root of 3. We don't have a calculator. We're not going to use a calculator. If you put 4, you're going to get 2. 5, square root of 5, and 6, etc., etc., to 9. 9 is going to be what? 3. So what happened is, if I had to represent this value in the graph, now we go. When X equal to 0, 0, 0, 0, 0. When X equal to 1, the value of Y is going to be equal to 1 also. When X equal to 2, when X equal to 2 is going to be square root of 2. Square root of 2 is somewhere here. When X equal to 3, it's going to be square root of 3. Somewhere here before 3. So, and X equal to 4, etc., etc. X equal to 9 is going to be equal to 3. So this graph is going to go like this. Okay, so that's a graph which is going to be Y equal to square root of X. So I'm saying, so for that reason, excuse me. So for that reason, this is a function. You know why it's a function? Because if I draw a vertical line, it's going to cut only once at every point. And that's how we test a function. Man, what you mean? You even, because isn't that when you square root this number, you have to get plus or minus? Isn't you have to get plus or minus, and this graph should go like this? You know what I'm saying? Because somebody could say, oh, if you square root here, in a square root of X means you're 0. But when you square root to 1, it have to be plus or minus. But according to the question, let's come to the question. They say X are all elements of real number, but a Y equal to positive square root of X. Positive square root of X. So for that case, excuse me. So the relationship, excuse me, this, according to the given question, it denote only positive. You get what I'm saying? It's only denote what? Positive. So for every value of X, for which is square root of X, there's a unique value of Y. Unique value of Y. Hence, please don't mix this one, so excuse me, with Because if it is like that, then it's not going to be function. If it is plus or minus x, this is not going to be function because it's going to come like this one. You get what I'm saying? Because you're going to get plus or minus, means for each value here. Remember, when you square root anything, for example, square root of 9, this is going to be plus or minus 3. Square root of 16. Square root of 16, it has to be plus or minus, or minus 4. So if this was plus or minus in a given equation, and then also this graph was going to come, because for each value we could have a plus or minus. So plus that one, and minus was going to come to the bottom, meaning the value of y was going to be both for each. So for each is going to be plus or minus 2, means if it's 4, it has to be plus or minus 2. Then our graph was going to come like this, which if you do vertical test, it couldn't, there was no way it's going to be function. But according to the given question, they only say, the set of a function whereby x are elements of real number and this y equal to positive x. Is it a function? Yes, it is function, man. It is function. You see what I'm saying? It is what? Function. I agree it is function. So hence, yes, it is function. So this denote only positive root. Only denote what? Positive root. You see what I'm saying? So I'll go for A and C. You see what I'm saying? I'll go for A and C. So my answer is A and C. Please, like I said again, don't confuse this stuff here and two different things. You know what I'm saying? This one and this different. You know what I'm saying? So here we go. So for this case, I'm gonna take A and C. So let's go to the options. A and C, option 4, I'll say, excuse me. Question 4. Question 4. So the question 4 options going to be, has to be B and C true. B. So question 4, B and C true. So option 4. Question 4, option 4, B and C are true. So I'll go for B and C. So option 4, I'll go for B and C.